Hi guys, it's me UBprogrammer and welcome to the lecture 4 of Digital Logic Design series. And let's start the lecture. 32-bit system can represent 2 to the power 1 to 7 as the largest number and 2 to the power minus 1 to 6 as the smallest number. So we have seen that 32-bit representation here, and if we want to store a number or deal with the number beyond this range, so this positive and negative number, really big number this is, but if we want to go beyond this range, the either way, the positive up to positive side or the negative side, we have to use the 64-bit system, which is most of the modern system nowadays, right? Modern system use this 64-bit system, and it is also called the double precision floating point format, right? So this is another name of this system. In this system, the first bit is obviously representing the sign of the number. Next 11 bits represent the exponent, so we have increased the exponent by 3 bit if we compare it to the 32-bit system, and then the remaining 52 bits will be used to represent fraction or mantis apart, right? And other ways to represent binary numbers. So till now we have seen 4 ways, which is unsigned representation, where we can't represent the negative binary number. Then we have seen the signed representation, where we use a bit, an extra bit, to represent sign. And then we see the 2's complement. Then we see the floating point notation, just like 64-bit or 32-bit floating point notations. And then we have more 3 ways to express binary numbers. Let's see that now. Access code, it is to represent the exponent. So this 11-bit or 8-bit in the 32-bit will be represented by using this system. We will not go into details, but these are there just to let you know, right? And the BCD code, this is used to represent the decimal numbers. When we are dealing with numbers from 0 to 9, we use that, just like in clocks, digital clocks, we use this system, BCD code. The grayscale or the gray code, it is a non-positional code. Everything we have seen till now is the positional, except for the Roman. I have talked about that in earlier lecture, and just like that, the gray code is the non-positional, and it is used in the machinery systems and especially in the rotation tasks of the machinery in the disks, right? Okay, so let's talk about the ASCII. So this is the American Standard Code for Information Interchange. So we have come to an agreement. So by we I mean the world, the whole world has come to an agreement on the representation of the characters, right? So it uses 7 bits. The default ASCII standard shows the 7 bits, so you can guess the range of character it can represent is 2 to the power 7. And there is an extended version of ASCII which can represent 2 to the power 8, so 256 characters, right? And 0 to 9, we have it starting from this number, from this A to Z have this range, and capital A to capital Z have this range allotted to it, right? And these are for the symbols. And there is an other standard called Unicode, which can represent 2 to the power 16 characters. This is really a large number, right? So everything will be included in the Unicode. It's still an ongoing process, right? Because there are really large number of characters in there, right? So that's it for this video. I hope you like it, and I will see you in the next lecture, which is 5. Thanks for watching.